Hello all. So now I'm going to share with you some of the information about MIPS instruction set and QtSPIM. So starting from the next lab, hopefully we will be getting 4 labs. Maybe in one lab we will be uh, performing the examination, but 3 labs we will be getting, and in those 3 labs we will be learning about MIPS instruction set and QtSPIM. Although we cannot learn everything about QtSPIM in 3 labs, we will be continuing this in the next semester course, which is computer architecture. I'll give you very brief information about MIPS instruction set. So MIPS architecture, it supports these following data types: byte, half word, word, which is 32-bit, float, 32-bit floating point number, double, which is 64-bit floating point number. So these are the data types that it supports. Memory is byte addressable. One important thing you have to understand that in QtSPIM, it is simulated and the words are stored in little endian form. There are 2 ways of storing the words in memory. One is little endian, another is big endian. So we will discuss about this in the lab itself with an example. There are many registers. So these registers are built in the CPU itself, separated from memory. So as I told you, these are processor registers. And it has 32-bit integer registers and 32-bit floating point registers. There are 2 set of 32 bits register. One is 32-bit floating point register, one is 32-bit integer registers. And some of the registers are special purpose registers like stack pointer, also the return address where it is stored, etc., etc. So we'll look into all these things. So this is the various, you see, these are the various registers, numbers that are generally used when we consider basically when we write assembly language code using this MIPS architecture. That is what we will be doing using QtSPIM. Zero is always, this is a register 0. So this is the register number $0, which is always set to 0. So we need a variable which is initialized with 0. So this is the variable which we can use to initialize something with 0. We'll look into all these things in detail. At is basically a similar temporary thing that we store $1 there. V0 and V1 are $2 and $3. Here the function results are stored. Low and high bits are used for representing that. A0 to A3, that is from $4 to $7, 4 registers are used to store various arguments. We will see which all arguments. Basically, the arguments are for printing some string into the console, for um, uh, getting some data from the keyboard, uh, printing an integer into the keyboard, loading an address, and there are few more. We will discuss about that later. Now these are temporary registers. Temporary registers are from $8 to $50. We can use these registers as temporary registers. And from $16 to $23, these are safe registers. We can store certain values here. Again, $24 to $25 can be used as temporary register. That means whenever you are performing certain when you are writing certain programs, the code that you will be writing, you will need certain registers. So the temporary registers that you can use for your coding are basically these: $8 to $50, $24 to $24 to $25. And these are reserved for OS kernel and we cannot use it. So there are certain registers which are fixed for certain purpose in this particular architecture, MIPS architecture. So we will not be using those for our general purpose work. So for general purpose work, for coding, for writing programs, we will be using these temporary register. As I said, there are certain reserved registers. These are some reserved registers and should not be used by user programs. There are some miscellaneous registers as well, like PC, status, and other registers. So these stores the value of program counter. You already know what is that. Also status register. Status register basically is a register where various bits contain the value after operation. I discussed something like this, that after you add two numbers, and if the number is, let's say, positive or negative, fine, then generally what happens? What happens basically, if the number is negative, or you sometime may feel that uh, basically you, when a number is negative or positive, you may need to represent it in some way or the other. So we will see that how we can do it here. Okay, so let me just swap the presenter view and let's move on. Now integer representation. Integer representation, like, see, this is for an unsigned, the range is, for unsigned, the range is from, for an 8-bit 02 to 55, and for signed the range is -128 to 127, and so on and so forth for half word and word. Word is 32-bit and half word is 16-bit. You can use all these things in QtSPIM. Two's complement you already know. You can also check this by doing it using certain instructions. We can discuss that in the lab itself. Now, for using QtSPIM, it is very straightforward. I will be showing you the tool itself, but prior to that, I'll discuss some of the important points of this tool. For the comment line, we use hash. Remember this always. Anything we start with hash is a comment line, right? Assembly directives informs the assembler for data declaration. There are certain assembly directives which informs the assembler that, look, this is the data section, this is the text section. That means data section is where you initialize the data, and text section is where you write the text. So about text and data, it should begin with a dot, like dot data means the data section will start. Dot text means the text section will start. The general format of data declaration is basically, and for a data declaration, there are various types of data, like, you know, integer type. In C program, you have seen integer type, float type, and many other types. Similarly, here also you have to define certain variables and certain data types. Like a variable name, if it is sum, you have to write sum, then colon, okay, then the directive, what kind of data type it is. So this is dot, let's say, word, which is 32-bit. And what is the initial value? Let's say the initial value is, I'm initializing 0, like this. So this is how you represent it. Let's move on. Now, as I told you, these are the directives or the data types that are supported, which is byte, half word, word, ASCII Z. One is null terminated and another is not null terminated. This is float, this is double, and this is space. Okay. So these are the following data types that you can use in QtSPIM for MIPS programming. Now, for data movement, you know that this is your processor and this is your memory, right? And you have to load data and instruction from memory to your processor. So for doing this, basically, we need certain instruction. So we load value from memory location. You know, I have already told you. So there are specific instruction based on which only load and store instruction are used for getting the data from memory to processor. No other instruction. Earlier we were doing, like, let's say, add R1, LOCA. we cannot use such kind of instruction here. Here, only these two kind of instruction can be used to load the value from location A into one of the registers, and then we perform the operation. This is how this tool works, because this is how the MIPS architecture is laid down. Like L type, first is the destination, and then what it basically does is that load value from memory location into destination register. So memory location, what the value will be loaded here. Similarly, load specified immediate value into the destination register. Load immediate means it will load an immediate value into some register. LA means load address. Load address of the memory location into this register. RDEST is the destination register. And store content of source register into memory location this. So that is store word or store byte, anything. So we need two types of data. Sometime from processor to memory, we need to write something into the memory, and we also need to read something from the memory to processor. So we also need to write. So for writing, that is, we call it store basically. So this is how it is done. Now these are some of the examples. Basically, I told you num, this is the name of a variable which is type dot word whose value is initialized with 0. Similarly, this is wnum, which is dot word which is initialized with 42. And similarly with, let's say, Hans, which is dot half initialized with 0, and so on. Now to perform basic operation, what we need to do? If you see this set of code, okay, we already discussed something. Now this is nothing but some instructions which is doing what? Load immediate value. So 27 is the immediate value which is loaded to some temporary register T0. Okay. Now store word. I'm using an instruction store word where this particular word which is in $T0 will be stored in this memory location called num. So now if you see what is in num will have this value 27. See, num equals to 27. Similarly, you take this load word. Load word means this wnum. What is there in wnum? Wnum contains value 42. Okay. Now store word $T0 where $T0 equals to 42. This wnum will get stored in store word. Okay, so we have to store in WANS. In WANS, we will be storing what? $T0. So what is $T0? $T0 contains 42. So in WANS once we will have wnum, which is nothing but this 42 value. Okay. Load word. This whole word will get loaded there. Then store word. This word gets stored here. Load half. Half word will get loaded here. And then store half. The half word will be stored here, and so on and so forth. This is how this whole thing works. Okay. Let's move on. There are other instructions like move instruction, but these instructions are very much like transferring or moving data from one register to another. There are various forms of it. Move, this is the destination, this is the source. From source it will get transferred to destination, and it has got various other forms of the same instruction. We will be looking into all these things when we look into the programs. There are other integer arithmetic operations. These are like add. If we just use add, that means this is add unsigned. Okay. and it will add source with two source, and the result will be stored in destination. Okay, so basically this is three address instructions. So there are three particular, basically three instruction operands are present. Three operand instruction, you can say. Okay. Sub again, same way, our source will be subtracted from our destination. So this is how it works. Similarly, there is mul. Similarly, there is mul, and also there is div. Okay, there is also some instruction like other like rem, which is basically nothing but the remainder, absolute, negate, and so on. Okay, so there are set of, these are arithmetic operations. When you execute by yourself, you will look into these. When you write your own programs, you will come across with all these instruction and yourself see how this instruction actually get executed in MIPS architecture. Okay, these are set of logical operations like and, nor, not, or, rotate left, rotate right, shift logical left, shift right arithmetic, shift right logical, XOR, etc. etc. We already did how shifting is performed. So I'm not discussing this again here. You already know what is arithmetic right shift and left shift, etc. Now, this is something important, but to be very frank, we will be not dealing with control instructions in this semester. We will be dealing with this kind of instructions in next semester. But for your information, there are various kinds of control instructions. Control instructions are needed when you write programs. And there are unconditional control instruction and there are conditional instruction. These starts with jump, basically. Jump to a label. Label means it will jump to a particular memory location where that branch basically takes place. So we'll look into all these things when we actually do this in the next semester. But in this semester, we will be executing simple instructions and we will see how QtSPIM actually works. These are some of the conditional statement which I'm not discussing right at this moment. Basically, branch if equal, branch if not equal, etc. Now, let us come to this point, QtSPIM. I hope all of you have installed QtSPIM. I will go there, but this is how it looks like. You see, this is how it looks like. Here you will see that the hexadecimal address. Okay, and here is the encoding, instruction encoding. Okay, and these are nothing but the instruction. You already know these instructions are nothing but bits of zeros and ones. How these instructions are represented in MIPS, it is given here. This is the encoding. Okay, we'll look specifically into some of the instructions one by one. Okay, so this is how the entire tool works, and once you execute the code, various registers will get initialized with certain values after the operation. Okay, here we see that these two registers, okay, which is A1 and A2, is initialized with certain value and so on. So we'll look into this. Okay, this is a typical screenshot and you will see many other options here. We will see one by one when I'll show you that. Now, this is a sample. Please look into this. This is MIPS 32 layout. Okay, so how do we do this? Basically, there is a text section, which is basically the code section. Now, this global main, you know that in C, the execution of the program starts from main. Similarly, dot global main means this is the starting point and must be global. That is why this is the directive. So whenever a dot comes, it will check what it is. It will see it is ELO BL. That means it is global main from where it will start the execution, that is main. And now under main colon, we write the program. Okay. Under the program, there could be, this is where we write the user program. One part is the data section, and another part is basically the program, the text section. Okay. So these are some of the assembler directives, that is .text, where user text segment which contains the instruction. So whatever instructions, like I need to add 2 numbers, right? So that will be stored here, okay, in the text. And in the data section, we'll specify the data segment. If we need certain data from the memory, those things needs to be specified. Okay. Global SIM, so specifies that the symbol SYM is global and can be referred from other files. So within your set of files, if you have initialized one program as one name of a variable as SIM, which is global yellow BL, then it can be accessed from other files as well. Dot word is the word, which is each word is 32-bit, which is stored in memory. Dot half is basically specifies the 16-bit number in successive memory half location. Okay, so this is how it goes. There are others like byte, ASCII. ASCII is something you come across, stores the specified string in memory, but do not null terminate. Similarly, strings are enclosed in double quotes and follow C-like convention. Fine. And ASCII Z, it stores the specified string in memory and null terminate. You can see with example what happens if you write initialize a word with ASCII and initialize a word with ASCII Z. You will do it and you will tell me whether this is working or not. And dot space is number of space if you want to give. Okay, we can also give that. Now these are the registers. I told you in the very beginning, these are the registers that you can use, and these are the ones which are used for different purposes. You see, this we can use for temporary, not saved by calling, but this are some of the registers which are saved by calling. Okay, so we basically can use all these registers for our programming. So pseudo instructions, the MIPS pseudo instruction, we did not discuss it before, but there are certain pseudo instruction. Basically, all instructions cannot be directly executed. So there are certain instructions which are called pseudo instruction, which are converted into real instruction and then get executed. There are many instructions which are basically pseudo instruction. SPIM converts these into MIPS 32 instruction before executing. So this is the responsibility of the SPIM simulator, which converts these into MIPS 32 instruction. This is something very important, and please see it in details because this you need to do it. Now, for printing an integer, you need to initialize certain values in certain registers, and then you can execute it. Now, why this is required? Okay, think of a situation like when you already did C programming. In C programming, you have entered something from keyboard, and from the keyboard it got into your program. But how it has got from your keyboard to your program, and then when you write print, it got printed in your screen, which is also an output device. So keyboard is an input device and screen is an output device. You think of scanf was used for entering data into your in your memory, right, from the keyboard into the memory, and that is why you used to use percentage ampersand a or anything which you want to enter. Similarly, for printing that into the screen, you used to do printf %d and then you write the value. So basically what happens here, you are dealing with there's a concept called operating system. So operating system, under operating system, there is something called system calls. So basically, for using the computer hardwares like the keyboard, the monitor, etc., you need to have a permission, and then you need to tell the computer through system calls that I need to print this value into the monitor. I need to enter the value from the keyboard. So these are basically performed in that way. So when you execute in C program also you have done in that way. Here you are going little more lower level and executing it. And for that reason, you need to do this. What you need to do? There are certain register $V0, which is 1, and there is certain register $A0. Okay. Now, if you want to print an integer into your screen, okay, which will be displayed in a monitor, then you need to put this value 1 into V0. Then you have to put that number into A0. That argument must be put in A0, and you have to execute something called this call, system call. That means I'm asking the system to perform this operation and print it into the monitor. Similarly, for printing string, it is 4. And in A0, you have to store the address of that string, from where you have to print that string. Similarly, for reading an integer, it is 5. And the result of whatever is stored in V0. Reading an integer is 8. Reading a string is 8. A0 stores the address of the buffer and A1 the length. Similarly, for exiting also, it is 10. These are the codes that you need to put in one of the register, that is $V0, and then you can execute it. So the reason for doing this is that for executing any instruction, that is where you are using the hardware. Okay, that is you want to enter something from the keyboard, or you want to print something into the output device, which is the monitor here. You need to perform this syscall. Okay, we'll look into the details in operating system course and others how the system call works. But for now, you understand this. So for printing, you need to do this for this QtSPIM. Now, this is very important. You have been doing instruction encoding, right? You have already done all these things. Now, how instruction encoding is done in MIPS is based on this. You see, in MIPS, there are 3 kinds of instruction. One is called R type, one is called I type, and one is called J type. R type is basically register type, I type is immediate type, and J type is basically jump. Okay. Now, for all these things, there are some specific number of bits allocated for it. Like for R type instruction, see 26 to 31 bit is for the opcode, and 0 to 5 bit, last 6 bit, are used for what specific kind of operation you are performing. Okay, so this opcode and this function are related. You will see that these two values are same for a same instruction, okay, and different for others. Similarly, this is the RS is the register source. This is another register source, and this is RD is the destination register. So for an instruction add, if I write R1, R2, R3, then this is basically my destination register. So this is one of the source operand, and this is another source operand. So R3 and R2 will be stored in here and here, and the destination will be stored here, and same way. This is a shift value. Let's not discuss this later, but this is saved for some purpose, right? So this is how the encoding is performed. Similarly, I type instruction. Here is the opcode. Here is the source. These are the two source, and this is the immediate value. That is okay. This is how the encoding is done in MIPS. Fine. So this is a specific way that this is how the encoding works. In QtSPIM, you will look into all these things. Some instruction requires 2 registers. We will see why it requires 2 registers and so on. Now come to the program. You will be executing these instructions and you will see how this works. So I'll just take this first example and then go to QtSPIM and we'll work with show you how you have to execute it. Add 2 numbers in memory location and stored in memory location and store the result in next location. Now use dot text dot global mean. Okay. Now the value. Value means value is a kind of memory. Starting with value, value will have certain memory address. The first is 50, the next is 30, and the first location contains 50, the next location contains 30, and the last location contains 0. Okay. Now execution will start from main. Now see what I'm doing in main. We are loading load address value. So value means this is of course this is a location in memory which is named as value. That value will get stored in T0. And now I will load the word in T1. Load word from this memory location $T0. $T0 contain the address. So from this I will get the value. Similarly, load word. Now it is a 32-bit computer. So the next word will be stored after this is a 32-bit thing. So the next address will get incremented by 4. That is why I'm loading the next word from 4 plus 0 plus T0 is nothing but if T0 is, let's say, some address 2500, then 0 plus 2500, from this memory location I'm accessing the first word, then 4 plus 2500. So I'm accessing the next word from 2504 and so on and so on and so forth. We are doing. And finally, then the 2 words you see are in T1 and T2. And finally, I'm adding T1 and T2 and storing the result in T3. After we get the result in T3, then we store the word, okay, from T3 into the memory location, the next location. This was, let's say, 2500. The next is 2504. The next will be 2508. That means initially 2500 was stored in T0. So T0 plus 8 will be 2500 plus 8, which is this location where I will be storing T3 after adding 30 and 50, whatever will be the value, that is 80 will be stored there. Okay, but in QtSPIM everything will be stored in hexadecimal form. So you will see that you can convert it. You can see. Okay, I'll stop here and now I'll go to the screen and I'll just do it. So let me come out from here. So you will be doing all this, sharing this PPT with you prior to the class so that you can perform it. Now this is QtSPIM. Once you install QtSPIM, this is what you can see. Now see, this is the text, the code, program code, which you will be writing. What you need to do, you will be writing in, WordPad, anywhere, a set of code. In a WordPad, you will write a program and you will save the program with the extension .asm. So I already did this. See, this is a very, very, very small program, sample program. Okay, this is the sample program for adding 2 numbers. Okay, now what it says, .text .global main. So it starts from main, an instruction or immediate. what I'm doing here, I don't have any data section. I am just adding 25 with 25 and storing it in T4. Okay, let's see what we are doing. Initially or immediate, I am doing, this is T2, comma, $0, comma, 25. So tell me, if you OR a number with 0, what will happen? OR means 0 and 1. If you OR, it will be 1. So the same number will remain. So T2 is initialized with 25. Fine. Similarly, OR immediate, again I do, where I initialize T3 with 25. Okay. So this is the set of code that you have to write. And then I add T2 and T3 and store the result in T4. And finally, I have to exit. For that, I'm loading an immediate value 10 into V0. You remember, recall what I said, recall what I discussed here. You go to this. For exit, we have to load in V0 10. Okay, we have to store an immediate value 10 into V0. That is what we are doing in QtSPIM. See, that is what I'm doing it here. So li $V0, 10. And then I write a syscall. That means this will exit. Now, I will execute this program. First of all, you have to write this program, save it as .asm file. I have saved it. So you see in my folder, let me see where I have saved, under ASM program. Okay, under ASM program, this is testad. See, this is ASM file. Okay, this is the sample ASM file that I'm dealing with. Fine, but you please remember to save it as .asm. Okay, I'll share with you some sample ASM files so that it is easy for you. Now, how do we execute it? This is how this QtSPIM looks like. Now you see, this is the text, this is the data section. We will look into all these things, what it is storing, etc., in course of time. First, let us understand what happens. Now you see in the left side, PC is there, right? Now these are the various registers that we were talking about, starting from R0 to R32. All the registers are stored here. Okay. So these are all the registers. So it's not going down this time, or maybe for some reason. So anyway, we can see most of the values. Firstly, when you want to run that program, which we have written, so we have written this program testad, okay, where there is 3 lines of code basically, and then we exit. Fine, you understand this. We have been doing this for a long time. Now I'll do file. See, there are load files. We will do reinitialize and load file. Reinitialize means it will reinitialize everything, and all other values which were initialized with something else will now get initialized with a new value. Okay. Now see, I have loaded this. Now you see this set of code. This is standard for a QtSPIM. Just JL instruction jump. Okay, this is jump to main instruction says that your program starts from 004 00024. This is where the main start. Now this is where the PC will point initially, and slowly it will point to the final one after syscall. Fine. Now you come here, which is see 004 00024. Where is that? It is here. It is this one. This is my first instruction that I have written. What was my first instruction? Remember, ORI $T2 $0, 25. So see, this is $T2 $0, 25. So I was using T2 in the instruction. Again, go here. See what I'm using, T2. What is T2? T2 is basically R10. Okay. Initially it is initialized with 0. You see, all is initialized with 0. Now I'll execute it. How do you execute it? See, this is the run symbol here. Okay, so you click on this. Once you click on this, now see what has happened. In the program, you have entered this 25 is in decimal. Now T2 is initialized with 19. What is 25 decimal? You convert it to hexadecimal, it is 19. Similarly, T3 is also loaded with 19. 25 and 25. Now, after addition, the value is 32. What is 32? 32 is 50. 50 in decimal is 32 in hexadecimal. So now we have successfully added two register value with 25, and this is the result we got. Now we'll change the program. We'll change the program with simply this value with 50. Okay, and we'll save. I saved it. Now I'll go to QtSPIM again. Now again I'll click on file, and then we'll do reinitialize and load file with the same code. Okay, now see, it has got reinitialized. All are 0. But now you see here, earlier it was 25 and 25. Now you see this is 25 and I have changed there, so this has become 50. So whatever you are writing there, the exact set of codes that are needed to execute this program is saved here. Okay, and now you click on run. This is the symbol, small r triangle. Click on here. Okay, now you see this is 19, 32 is 50 in hexadecimal. What is the final result? You just do it, it will come as 4p. Okay, so basically this is very simple, and now we will be seeing a lot of things. What you will be seeing, what is this? This is the instruction encoding part. Now you will do it and tell me why this, how this instruction is encoded as this, which is 340A0019. Why this instruction is encoded as 340B0032 in the next class. Okay, so this is what I wanted to discuss with you about QtSPIM. I will be sharing with you a couple of programs, and in the next I will be giving you certain assignments that you will be doing in the next 3 classes. In the next 3 classes, you will be doing some programs using QtSPIM. Okay. So that is all. I will stop the recording and thank you.